Uh, Hello, everybody. Thank you for announcing me. Once again, my name is Jakov. I'm Chief of Innovation in Balkans, which is a regional hub for Balkans area. And I'm leading our product lab. So today, I'm going to talk about Web3 for web developers. A lot of times I hear that the barrier to enter Web3 for web developers, for Web 2 developers, is big. They are often confused. They need to start learning new languages, which, well, is not always easy, and you're maybe wasting time. You don't know what will be going forward. So today's talk is just about that, how to lower this barrier of entrance and how to make blockchain and Web3 accessible to everybody. And in the beginning, I already put my Twitter and Telegram handle. So if you want to reach out to me afterwards, remember it, but also on the last slide, I'll show it again. So if you miss it now, you can get it later. Before we start, how many of you heard about NEAR? All right. How many of you developed on NEAR? OK, not so much. How many JavaScript developers do we have? OK, good, good. Let's move on. So this is the agenda for today. Thank you, Camila, for explaining blockchain, how it works. Now I can actually move to application layer. So we're going to compare applications versus decentralized applications. What are the differences in the architecture, but also in the development process. After that, how to develop the apps. Bit of intro to NEAR. Why is it different? What it provides to users and developers. And the main point of this presentation is cross-section between NEAR and JavaScript. And in the end, we're going to have a live demo, short one, because tomorrow we'll have a big workshop by my colleague, Andrei, so he can dive deep in the code. This QR code is a link for NEAR's documentation, developer documentation. I honestly recommend it. It's pretty good. Quick start guides and everything to get you started very quickly. OK, so what is this? These are actually two different architectures of applications. The left one looks familiar. It's a normal Web 2 application, very simple one. So what do we have? We have a user that is interacting with the client. Client is maybe some kind of web app or mobile app, doesn't matter. We have some kind of server. It can be a backend executing business logic. And we have a database. Database is used to store all the data that is modified by the server and so on. Later on, it can be retrieved and stuff like that. So this is very simple. In blockchain, in decentralized applications, it's not much different. So again, we have a client. And this whole server part is actually replaced by a couple of things. So we have smart contracts. These guys are actually software that is running on blockchain, and they are executing your business logic. And all this data is not stored in one database. It's actually stored in blockchain, which is acting like a database. What is different? You don't want to abuse your database because blockchain can get costly quickly. So you want to optimize your application and only put data on blockchain that you actually need, data that actually need that immutability and trustlessness. Everything else can be then offloaded to client, which can also be decentralized if you deploy it on decentralized storage providers like IPFS or similars. We have a wallet, and we have an RPC node. So Camila already explained RPC nodes. These are your entries to communicate with blockchain. And the wallet is a software that is actually containing your private key, and it's used to sign messages. So each client, each user, actually not client, but each user owns a private key. And that can be like compared to JWT token. It's used for authentication. Whoa. OK. Cool. It's used for authentication, but you should really keep it private, because anybody who has your private key has the access to all your funds, all your assets, and everything else. So this wallet is just using your private key to sign the transaction, and then the client is distributing this message to the RPC node that then distributes it further in the blockchain. If the transaction is valid, the change of the state is applied. We can see that in more details on the next slide. So here we have a wallet, signed transactions. There are actually two different types of function calls. One of them is just reading contract state. So it's reading state from the current block. And those calls are free. Why they're free? Because they're not modifying anything on the blockchain in the distributed database. They're just reading. But if you want to put modified state, if you want to change something, you will have to pay with gas. OK. So how to develop decentralized applications? This is in general. This is not just for Near. This is in general for multiple different networks. So I already explained you what are the components of decentralized applications. The most interesting part for newcomers are smart contracts. And they can be written in a variety of different languages. The most popular platform is Ethereum and Ethereum Virtual Machine. And contracts for Ethereum and EVM chains are written in Solidity and Viper, mostly. You should stick to those. Both of those languages are only used for blockchain, which means that if you want to use them, you will have to learn them. But then we have some other blockchains, for example, Solana, previously Terra, and also Near, where you can write contracts in Rust. So that is interesting because Rust is not a domain-specific language. Rust you can use to write any kind of backend. And very, very optimized code can be written in Rust, very performant code. You also have Cairo, for example. This one is very new, very interesting. It's used in StarkNet because you can produce zero-knowledge proofs out of it. And we have JavaScript or TypeScript, and that is very new. That is very new, and that is very good because a lot of people know JavaScript and TypeScript. So you can skip the Solidity and Viper part or Rust part if you have never developed in Rust, and you can move to JavaScript. Once you deal with smart contracts, you have a UI interaction with blockchain. As I told you, that can be any like web application or mobile application. And to develop that, like barrier of entry is very, very low. You already know it. You write regular front end with some like popular frameworks, for example, React.js or Vue.js. And you just import some JavaScript libraries that are responsible for communication with blockchain. What can also help you, this is not mandatory, but super useful, are dev toolings. Of course, you can write everything manually, compile manually, but that's quite hard work, honestly. You will want to use some kind of developer environment. And they will handle the whole flow. So it usually goes, you write some code, you compile it, you write some tests, test the code, and then maybe you will first deploy on a testnet or a local devnet. And then once everything is ready, you deploy it on mainnet. I already mentioned that you maybe want to deploy it on a testnet or local devnet. That's where devnets come super useful. So you don't want to deploy your application each time on mainnet and test it there. First of all, it's quite expensive. And second, it's very, very slow. Testnet solves that, solves the cost problem, but still it's very slow. Imagine a test suite of, I don't know, a couple of hundred tests, or maybe 1,000 tests, and you have to wait for each one to actually get included in the block on the blockchain, wait for result. It's super slow. It can take hours. So you have devnets, which are tools that actually run everything on your local machine. You can configure them to produce blocks every second or even faster, and that reduces your development time quite a lot. Plus, you have block explorers. These tools are useful for debugging, for tracking transaction interactions on blockchain, and all kinds of interesting things. All right. Let's talk Near then. What is Near? Near is a layer 1 blockchain. It's a so-called monolithic chain. Why is it interesting? It's proof of stake, but it's also dynamically sharded proof of stake. So what is sharding, first of all? We already have sharding in databases, and now we have them. We also have sharding on blockchain. So this is type of scaling. This is a mechanic to scale blockchain, where we can actually shard both execution and state. So now your nodes, your validators, don't have to hold the whole transaction history, don't have to execute each transaction that is distributed in the blockchain, but they're actually sharded, so each set of shards is responsible for some set of transactions. So what is dynamically sharded proof of stake? We can compare it to something like elasticity on cloud providers, on AWS, for example, where once the utilization goes up, we add more resources. So the chain is more performant and it can handle more transactions. Because on blockchain, you have a block of a limited size. Once you fill it, your transaction needs to wait. But of course, that increases demand for resources and everything for validators. So once the utilization goes down, what do we want to do? We want to do the opposite. We want to actually reduce the number of shards and reduce the requirements for performance. NEAR is scalability and usability focused, but not only for users that are interacting with the blockchain, but also for developers, as you will see with this NEAR.js SDK. It has a super interesting account mechanism. If you ever used Ethereum, for example, your addresses are represented as hexadecimal strings. And if you want to have names, you have to use protocols on top of that. But NEAR natively has support for account IDs. So for example, I can deploy a contract to Jakov.near. It will not be some random address. My account can be also Jakov.near. We have sub-accounts, so it can be private.jakov.near if I want to send you some funds. You get the point. And it's completely carbon neutral. So if you know JavaScript, well, congratulations, because you're now a Web3 developer. I want to introduce NEAR JavaScript SDK. But let's start with some history before that. I want to explain how it started. So it started with JavaScript Enclave. What is that? That was a starting point where they created a virtual machine on top of NEAR that is actually implemented as a NEAR native Rust smart contract. If you're familiar with Aurora, which is EVM, Ethereum Virtual Machine, implemented in a Rust on NEAR, this worked in a similar way, but it was more like bare bones version. It's an isolated environment, and there was no like full interoperability. So the contracts that were deployed inside this enclave, inside this virtual machine, they could interact with each other, but they couldn't interact with the contracts that are NEAR native, which was very restrictive. And of course, since it was very early, it did not support all the standards. You had to write most of the things from scratch. And in general, it was good for learning, to start getting involved in the Web3, but for production, still you had to learn Rust and move somewhere else, or Solidity. But now, we have NEAR.js SDK. And this properly enables like 14 million of JavaScript developers to get onboarded instantly. It's fully compatible with NEAR. So you write your product, you write your project in JavaScript, you deploy it. It can communicate with all kinds of different DeFi, NFT applications, metaverses, or whatever else is deployed on NEAR blockchain. Plus, also, it will be able to interact with Aurora contracts because they somehow managed to deal with this interoperability problem. So basically, like, there are no limits there. You can write in JavaScript and TypeScript. And honestly, if you want to start developing, I recommend to use TypeScript. It's just safer. It's nicer for both of you and your auditors. So yeah, I recommend to stick with TypeScript. And it's all run in a lightweight runtime. So how it works, basically, NEAR is executing WebAssembly, WASM files. So previously, Rust smart contracts were, of course, compiled to WASM, deployed to NEAR. And now this JS SDK also compiles JavaScript in the end to WASM and is deployed there. So it works very, very similar. OK, this is a cool slide to see actually how it looks like. So what are the prerequisites? If you're a web developer, you probably have already npm installed, Node Package Manager. So you just need to have Node.js. You will use near CLI to do all the interactions, so compilations, deployment, everything like that. And everything is done in JavaScript. So your contracts, your front end, your tests, everything is written in JavaScript. You use workspaces.js, and you don't have to learn anything new. We can move on. So yeah, this is the motto. Spend less time learning new languages, and you have more time to build. So now we have a risky part. We're going to have a short live demonstration. So hopefully everything will go good. OK. So this is what we're going to do. I'm not going to install Node.js, of course. I have it installed. We'll create a new JavaScript project by issuing this command. This will give us some boilerplate code. We'll take a look inside a little bit, see what's there, how it works, build it, run some tests, deploy, and see what is happening on chain. OK. OK, let me make it a bit bigger. OK, so let's run this command. So this is like interactive script. At this point, you can choose if you want to use TypeScript or Rust. There's also Rust SDK. For this presentation, we're going to stick to TypeScript. And since it will also generate some kind of boilerplate front end, we can choose if we want to use React or vanilla JavaScript or no front end at all. I'm just going to stick to React.js, name the project, shift demo. And do we want to do an npm install? No. Well, actually, no, because that will take time. I already have it prepared in another directory. But it gives you some starting points of what to do. Move there, do npm install, build, test, run, deploy. So let's actually go there. And let's see what we get when we actually do this. So we have a couple of directories. Let's dive into the contract part. That's the most interesting part. Source and contract TS. OK, it's visible. As you can see, this is full TypeScript. We import some modules from near SDK.js. We define a class, hello near, which is actually a contract. Here we have one string that is initialized to hello. Two very simple functions. One is view method, and another one is call method, where view will just return the existing state from the blockchain, which means that this transaction is going to be free. And call is actually going to modify the state and change the message to the one that you provide. As you can see, the logic is very simple, looks very familiar. This near log is just logging an event to show what happened on the blockchain, and you'll be able to actually see this in the Near Explorer. So now let's build it. All right, that's quick. We already built like both contracts and front-end part. So this actually is located here. We ended up with a new directory, which is called build. And inside, we can actually see some artifacts. This one is going to be deployed on blockchain. It's a WASM file. Here we also have like header file that defines method that are there. It's like interface. And now we can actually also run some tests. So let me show you that. We have a directory here, integration tests. Again, very simple ones. Let me make this smaller. So these are the two tests we're going to run. First one just checks if the string is initially set to hello. And the second one will first set the greeting to howdy, and then it will call the get greeting and check if it actually changed to howdy. Before each set, we run a sandbox environment, a local devnet, and set up the test account where the contract is going to be deployed. And after each, we just stop the sandbox. So we are ready for the next one. So let's run that, npm run test. All right, 2 tests passed. Seems like we are ready to deploy on testnet now. So let's do that. I'm going to run npm run deploy. And if I'm connected to internet, and as I can see I am, this is now actually going to deploy code to a live testnet network. So what it's actually doing, it's creating a temporary dev account that will be actually stored here in one of these directories. And it's using that account to deploy the contract. It's going to be located here in near dev. And this is the account name. The contract is deployed here, and we can check that by opening this URL. So I'm going to open it. And this will open our near testnet explorer. It's a block explorer. This is a transaction that was signed by this temporary account. And as we can see, actions, contract deployed, this one. Let's open it. OK. So currently, we have only one transaction. That was the contract deployment. But now when we start interacting with this contract, we'll be able to see all the contracts interactions here listed. So let's try to do some interaction. But before that, let's run front end so it's not all silly eye. OK. So this is our front end. And seems like I'm already signed in with my testnet account. But let me sign out so you'll see how it works for you when you start it first time. So it loads something from the blockchain. It says the contract says hello. So this is the initial greeting message. I'm going to log in with my near wallet. You can choose, this is wallet selector. I'm going to choose my near wallet. It redirects me to my near wallet. I already have my account here. So I'm going to choose next. And I'm going to confirm some network fee allowance of 0.25 near. So all the transactions up until 0.25 near will be executed without asking me permission each time to confirm them. Since these are very cheap transactions where I'm not attaching any additional near to do something like complicated, this will not take more than that. So we can now actually change this message. And I'm going to write hello shift web3 stage and click save. Since this is a live network, it actually needs to wait for the transaction to be included in a block. And now, as you can see, the message is changed. And if we go to the near explorer, and if we refresh this, we can see a new event, new transaction. We called method setGreeting in this contract. If I open it, it's signed by Jakov.testnet, and the receiver is the contract. And we have this log, message hello shift web3 stage. And you have some more details about the gas that is burned here, and all kinds of interesting information. Okay. This is more or less it about the live demo. I'm going to stop this. And I'm going to return back to my presentation. So this was just the introduction, so you can get some taste how it works, how easy it is to get a boilerplate code and to start modifying. After this, I would like to point you to this workshop. As I mentioned, it will be held tomorrow in a workshop room number 1 by my colleague Andrei. And you'll be able to actually try some more complicated examples. And after successfully finishing this workshop, you'll be like near certified. And to prove that, you will receive an NFT in your wallet. So yeah, highly encourage you to visit the workshop tomorrow. And this is a super interesting thing, because you actually attended this event and you've been on a Web3 stage, you can mark your presence here by receiving a proof of attendance. This is an NFT. It's called Hooked. The project is called Hooked. So you scan this QR code, and it will lead you to a claim page. In order to claim your proof, you actually need to have Near account, Near wallet. So if you don't have it, you will go to the wallet.near.org or My Near Wallet. It's a new one. Both of them are working. You'll create a new account. Once you have your account ID, which is something like this, it ends with Near, you go to a page like this, and you claim with existing account. You wait for the transaction to be executed, and congratulations. Now you have officially proved that you've been here. Question? Exactly. So this is not the only POAP or hook that you can claim on this conference. Visit our booth near Balkans Hub, and you can claim additional ones. So yeah.
So in the TypeScript code, first of all, can you hear me? Okay, that was a really, really great presentation. I love the JavaScript focus for traditional web developers. Can't wait to try it out, actually. But I see that, yeah, in the TypeScript that you showed, there was a decorator for like @call and @view, and there was an argument, and it was an empty object. What type of parameters would that take, and what would that do? Just out of curiosity, I just was wondering, just reading through the code.
Yeah, for all of these questions about the code, you should visit the workshop tomorrow, because he'll go more in depth. Yeah.
Okay, cool. That sounds great. Thank you.
Yeah, you're welcome.
I'm curious to know, are there any limitations to it? Like, if yes, like how do you guide a project? Like, yes, you should use the JavaScript version, or you should use the Rust one?
Yeah, definitely. Still, this is very early. JS SDK went live only a couple of weeks ago. So if you want to use it in production, it's ready. There are some limitations. So I wouldn't encourage you to write some decentralized finance applications, for example, in JavaScript. More like if you want to write some kind of game or NFT project, something with low value currently. If you want to write something, let's say, serious with high value, I would still stick to Rust, because this is very early. And the performance, of course, is not the same as with Rust. It's the same thing as in Web 2. If you want to write some performant applications, you will stick to, I don't know, C, C++, Rust, Golang. But if you want something to be done quick and easily, you will choose Python or JavaScript, TypeScript, and stuff like that. All right. Do we have any other questions? No? All right. Then I guess that's all. Thank you very much.